Hi guys, this is Mr. Adams from Midway High School, and this is a video on ethers. How do we name and how do we draw them? And as always, guys, I hope everyone is staying safe and following the guidelines. Okay, now before I jump into ethers, right, I was looking over a video I posted recently, and I gave this example in terms of how do you figure out the longest continuous number of change, right? And I noticed that I did this. I put the line around this guy right here, right? And we have 1, 2, 3, 4, 5, 6, 7, 8 carbons, right? And that gives us octane, right? Okay, so let me write that down, octane. But what I did, I kind of sort of covered this carbon right there. Now notice, how many carbons do we have hanging off the side over here? We have 2 carbons, right? So that 2 carbons hanging off the side should be ethyl. A couple of students emailed me and pointed it out to me, and you're absolutely right. Okay, Mr. Adams is human. So this name would be ethyl octane, and you will give the position of where the ethyl group is. So you can come from this direction, or you can come from this direction to give the lowest number, right? So let's come from left to right. Go 1, 2, 3, 4, 5. Let's come from this way. 1, 2, 3, 4. So you will call this guy 4 ethyl octane. So sorry about that confusion. It's no problem. Okay, let's move on. Okay, so ethers. Now they're recognized, right, guys, with the oxygen atom, right? But it's single bonded on both sides and it's attached to a hydrocarbon group. So what do we mean by that? There's oxygen, it's right here, okay? Single bonded, and there's some number of carbons on each side. It's very important, okay? It's an ether. Now, back in the days, they used to use them as an anesthetic. They don't use them anymore because it makes the patients really, really nauseous. And it's also used as a solvent in industry. It can dissolve fats and waxes, okay? It's sort of kind of very unreactive, and it's insoluble in water and volatile. It means it goes into the gas phase very easily. So I have a question for you. If ethers, right, are solvents for fats and waxes, insoluble in water, would you expect ethers to be polar or non-polar? Okay, so if you said non-polar, you're correct. Because remember, like dissolves like. Fats and waxes tend to be what? Tend to be non-polar. Or, water, right, is a very, very famous polar substance, polar solvent, the most famous polar solvent. So if it doesn't dissolve in water, you can assume the substance is non-polar, and that's what ethers are. Okay, so move on. Now, how do we name and write ethers? Okay, so here's what you do, folks. You will treat, right, the single bonded oxygens on both sides as the parent, right? And the hydrocarbons on each side, you would consider those guys to be branches. So here's what I mean. You would treat this guy right here, the oxygen with the single bonds, that's your parent. And these guys right here and here, you will call those guys branches. Remember, we said branches are basically alkyl groups, right? Okay, and they get a YL ending, yes? So if you have 2 carbons, right, what number is that? What prefix do I use for 2 carbons? I use F, right? Okay, F. And since it's a branch, I will say ethyl. It means it's hanging off the side. I have only 1 carbon here. So what's the prefix of 1 carbon? Meth, right? Okay. And since it's hanging off the side, we consider that guy to be a branch. Methyl. So we have ethyl, methyl up to now, yes? Okay. And in the end, all we have to do is put ether and you're done. Notice there's no numbers, folks. Now, you might ask the question, could I start from this side first, with the methyl side first? Actually, yes, you can. So if you said for this answer, methyl, ethyl, ether, right? You would also be correct. Ethers are very, very, very simple to name. Okay, so let's look at this example over here. Now I put under here, right? If you have the same hydrocarbon on both sides, right? Use the prefix di. Okay, so for example, I have two carbons hanging off the side there. I have two carbons hanging off the side there. I have two of the same group. These guys right here are the same. This is my parent, right? So what happens, you would simply call this guy diethyl ether, okay? And if you had to draw it, right? If someone told you draw diethyl ether, what you would do, you would draw your O first, your single lines, and it says ethyl, you put two carbons there, 1, 2, and 1, 2 on that side, and you're done. You fill the lines in. Now remember, guys, don't go bond happy, right? You know, carbon forms 4 bonds and oxygen 2 bonds, and you're done. Okay, so don't put bonds all over the place and you have too many or too little and so on. So be careful. Okay, but that's how you name and write ethers. Very, very simple. Now, guys, I want you guys to take these structures down in your on a piece of loose leaf or something and send them in to me later. On this side, right, you have to name them, and on the other side you have to draw the structures. Now before I wrap this up, I want to show you something really quick. I know we're naming these guys and some of us might be a little intimidated, but guys, here's the deal. There's oxygens, all these guys have oxygens in them, yes? Okay? But they're all different. Remember, you have table R at your disposal, right? So if you have an OH group attached to a number of carbons, automatically that's an alcohol, okay? Now, if, for example, you have an oxygen with carbons on both sides, a number of carbons on both sides, that's going to be a ether. Okay, so I don't want you guys to panic in terms of how to name or how to recognize or how to write these guys. Now, how do I differentiate between aldehydes and ketones? Aldehydes have this group. It's called a carbonyl group, right? Ketones have a carbonyl group, all right? But the biggest difference between them is that aldehydes always have a hydrogen next to the carbonyl group, right? And that aldehyde group is always at the end, okay? So the C double bond O carbonyl group with a hydrogen is always going to be at the end. Remember, we said we don't have to put a number for aldehydes because it's always at position 1. Ketones, on the other hand, the carbonyl group is there also, but on both sides of that carbonyl group, you have carbons, okay? So the carbonyl group is sandwiched between carbons on both sides, okay? So that gives you a ketone. So ladies and gentlemen, I don't want you to stress. Follow the pattern on table R in terms of how do you write and name these guys, and you'll be okay. All right, guys, so once again, this particular worksheet right here, I want you to do it for me and send it in. Remember, there's no hard and fast deadline for this, but please do it in a timely manner because we're not finished with the curriculum. We have other stuff to do, but at the same time, take your time and do it. And as always, if you have any questions, please email me if you have a concept is tricky. All right, guys, as always, hard work plus sacrifice equals success. We're going to get through this. Things are looking better. And so, stay positive. All right, take care.